Hey everybody, it's Mr. Roy. It's time to put a bow on our describing transformations of parent functions. So I want to kind of do a big overview of what we've learned so far, and then I actually want to take you through a bit of problem solving, because I think the thing we're missing up to this point is the practice and the skills necessary to do some problem solving. Bringing in Desmos, bringing in tables of values, bringing in descriptions of functions and their transformations, and putting the whole thing together. So that's what we're going to do right now. Okay, so if we've got some function, we're going to call it f of x, which we know we used to call y. So we're saying y is equal to f of x. If we do transformations to any function, we can describe them by the following. So here's our description that we saw yesterday. And this description, you'll notice, doesn't match any of our parent functions. It doesn't match a line or a quadratic or a square root function, like a radical function, or a reciprocal function, or any of them. This is a general way we can write transformations so that we can write the transformations and then they would apply to any function we would apply them to. Okay? So this is the general way to write it, and then we could apply it to lines or quadratics or anything, right? Anything we want. Okay, so these are our values we looked at. Let's remind ourselves what these different values are. So I'm going to get rid of my screen here. The first one, let's start with the one that's the easiest and the one we're most familiar with. So that one is just shifting up or down. We used to call this k when we were looking just at quadratics, but this is our one that's going to shift things up or down. If it's a positive value there, then we know that means that we are shifting up. If it's a negative value, it means we're shifting down. So that's going to shift us up or down by c units, however many that is. Our next easiest one is our horizontal shifter. That's this one right here. So that's going to shift us left or right, no matter what the function is, by d units. Now, one thing we need to remember is inside those brackets, when we're associated with the x values, it's going to do something a little, it's going to do the opposite of what we expect. So x minus 5, instead of moving us further in the negative direction, would actually move us in the positive direction. So we've got to remember that we need to shift opposite the direction of the sign. So x minus something would move us in the positive direction to the right. X plus something would move us in the negative direction to the left. Okay, so those are the ones that are a little more straightforward. The ones that can get a little trickier, we've got our k value right in here, and that's our horizontal stretch or compression by a factor of k. So what that means is horizontally, we're going to apply this to our x values only. So as you can see down here, I've written a little description. It says what we're going to do is we're going to divide our x values by whatever k is. If k is 4, we're going to divide all of our x values by 4. If k is a half, we're going to divide all of our x values by a half. Now when you divide by a half, that's the same as multiplying by 2. So if there's a fraction in there, it's going to kind of act like multiplying, okay? But you're going to divide all of your x values by whatever that is. If it happens to be a negative value, when you divide all of your x values by that negative value, it's going to change their signs. So if it's a negative number there, it's going to reflect it in the y-axis. Okay, so what that means is if I had my graph here, and let's say my function was this one right here, now it's going to reflect and it's going to be over there. Okay, our last one is our vertical stretch and compression by a factor of a. So whatever our a number is, we're going to multiply all of our y values by a. And if a is negative, that's going to reflect in the x-axis. Again, what that reflection would look like if we had, say, a quadratic up here, when it reflects in the x-axis, it's going to be down there. Okay? So kind of a nice, easy thing to remember is that everything that is inside here affects x values, and everything that is outside here affects y values. So that can be kind of a nice, easy way to remember it. And the things that affect x values behave opposite of how you think they would. So if something is multiplied by a k value, you divide all your x values by that. And our d value, we move the opposite direction than we expect, than the sign, okay? So that's kind of our big overview. This you're going to want to, unless you've got it locked into your brain, you're going to want to have this written down. So you may want to stop this video right now and actually write this down so that you've got it nice and handy in a good place. One thing I noticed is that for both the 11M and the 11U classes, your textbook doesn't have this in one spot all kind of summarized as neatly quite as I would like. So hopefully this will help you. So pause this right now, and if you think this would be helpful to you, if it's not locked into your brain, write this down. Okay, so we're going to move on. We're going to go through a couple of kind of quick examples, and we'll look at how we would apply these transformations. Okay, so here's our first couple of examples. It says here, describe how the following graphs can be obtained from the graph of y equals f at x. So you'll notice in our functions here and here and here, those are not any, those don't come from our parent functions, okay? Those are just written to tell us what the transformations are, and they can be applied to any function, okay? We can tell because it's got this little f in there, right there, and this little f right here, and this one right here. So that's telling us that we are dealing with some kind of function, but we don't know what the actual function is yet. These are just basically descriptions of the things that we would do, the transformations that we would make. Okay, so let's write down the transformations we would make to go from f at x to this one. Okay, so here we go. Let's write down what they are. For my first one, I see I've got something in the brackets with x and it's subtracting it, and I've got something out front multiplying it. I remember that that 3 out front is going to affect my y values. Now I always want to do, just like your BEDMAS rules, it's easier in this case if you're doing your multiplying first. So we'll think about those first. So my 3 out front is going to multiply all of my y values. So I'll say multiply y values by 3. And it's positive 3. So nice and simple. I take all my y values of what my function would be. Say I had a table of values, and I would just multiply them by 3. That's my first change. My second change, inside the brackets, x minus 2, I know that means I need to shift all of my x values to the right. That's the positive direction. Okay? I'm going to shift, so I'm going to say shift 2 units right. So that means I'm adding 2 to all of my x values. That's going to shift them to the right in the positive direction. Okay, let's have a look at our next one. Our next one has a whole bunch of stuff going on. So let's look at our first piece here. I notice I've got negative 1/4. So I'm going to multiply all my y values by negative 1/4. Now when I multiply them by a negative, that's actually going to change their sign, and so that's going to reflect it in the x-axis as well. So it's all contained in there. Okay, so multiply my y values by negative 1/4. My next one I see is right here. I've got 2/5 that's multiplying things inside those brackets. So I'm going to say multiply my x values by, oh sorry, not multiply, I hope you caught that. That should actually be divide, because I'm always going to be dividing by that. So I'm going to say divide, so I hope you caught that. My little mistake there. So divide x values by 2/5. Okay, now if you're dividing by a fraction, you could also turn this into multiplying and say I'm going to multiply by 5 and then divide by 2. Right, we could flip it. And so that's a way of thinking about it that might make it a little more clear. Okay, so dividing by 2/5. You could also just divide by 2/5 is 0.4. So you could also divide by 0.4. having it as a decimal. Okay, now our shifting. Let's do this one next. That order doesn't really matter. So we're going to shift 7 units down. And then this one inside, we're going to shift 1 unit. Since it's a positive, I'm going to move in the negative direction, so that's going to be left. Okay, so those are all the things I would do, and I could just do them in order if I had a table of values. Do those things. Multiply my y values by -1/4, divide my y values by 2/5, shift 7 units down, and then shift 1 unit left, and that'll take care of all my transformations. Now this one over here is a little bit funky because it can actually be factored. So this is something to watch out for. Okay, so equations have to be in the form where the k is out in front and the x minus h is in its own set of brackets. So this can actually be factored. Now we haven't spent much time talking about factoring this year, but these ones are going to be pretty simple. So I think you'll be okay with it. So let's just rearrange this. We're going to say f, and now I'm gonna divide a -2 out of each of those terms. So I'll divide out the -2, and I'll just be left with x here and -2 here. And I can see if I multiplied this -2 through the brackets, I would end up with the same thing I started with. Okay, so I factored that out, and now I'm ready to describe those changes. So here we are. I'm going to say first I'm going to take care of this one here. So I'll divide all my x values by -2. That's going to reflect it in the y-axis and make all my x values smaller. So it's going to be a horizontal compression. It's going to be a compression because it's going to make it smaller. And this -2 inside here is going to shift 2 units in the positive direction, so that's to the right. Okay, so that's how we would describe all of those transformations. We don't know what function it's applying to yet. This just describes we could do this to any function. So this is a general way of writing what those transformations would be. Okay, so let's actually look at doing some of these transformations to some points and some graphs. Kind of start with some simple stuff, and then we'll get a little bit of Desmos involved to try some of the trickier stuff. Okay, so here we go. We're going to try and do some transformations just of a single point. So this is a point that is on a function somewhere, the point 1, 1. Nice, easy one to start with. That's great. So in our little table, we can see that we've got just our starting function right here. And then we have a series of different transformations that we're going to do that are going to get increasingly complex. Okay, so let's start with our first one. There's a 3 that's inside the brackets with x. So remember that means I'm going to divide my x values by that number. So let's do that. My y values are going to stay the same. My x values are going to be divided by 3. So I'm going to end up with 1/3. So that's what that transformation would do to that particular point. Okay, let's change colors and try our next transformation. This is a totally different transformation, right? This one, again, has our 3 in our brackets, but it's a -3. So that means when we're transforming this point, we're going to keep our y value the same, and we're going to divide our x values by -3. So that means we're going to end up with -1/3 this time. Because it's a negative value, it's going to be reflected, it's going to be on the other side of the y-axis from where it was before. All right, let's try our third one. We're getting a little more complex now. This one has both effects to the x and the y. Now the x part here in the brackets, we already know, we already did that, so that's going to be -1/3. Nice and easy. But this one right here, the 5, for this one, now we're going to multiply our y values by 5. So 1 times 5 is 5. Okay, last one. Let's try and put all of this together. Whew, and a big tough one. All right, so let's look at our x values first. We started as an x value of 1, but we're going to divide it by -3. Okay, so we're going to end up with -1/3, as we've seen before. But we're not going to stop there. We're also going to be adding 2 to this. Okay, so this can get a little tricky thinking about trying to decide whether you're coming or going. But we're going to start with -1/3, and then we're going to add 2 to that. So -1/3 plus 2. You might just be able to do this all in your head, but if you want to do it by adding fractions, that's a fine way to do it as well. We could change it from 2 to be 6/3, right? So we end up being, adding them together, we've got a 3 on the bottom, we've got -1 plus 6. We're going to end up with 5/3. Now you could have written that as a decimal number, but hey, this is a nice fraction number, right? Okay, now let's have a look at our last one. We're going to have to do some changes here. We're going to do the same one we saw before. We'll multiply our y values by 5, and then we're going to add 4 to our y values. So multiply our y values by 5, we end up with 5, add another 4, we got a 9. Whew, okay. So 5/3 is our x value and 9 is our y value under these transformations. And that's just 1 point on our function. So you can see why we want to get into graphing software pretty quickly, because this can be exhausting. Okay, let's keep moving on. Let's try and describe some of these changes now. So I'm going to ask you to use some words from the list to describe the transformations indicated by the arrows. So here's our list of words on the left: horizontal, vertical, stretch, compression, reflection, translation, x-axis, y-axis, factor, up, down, right, and left. I'd like you to pause the video now, and I'd like you to have a look at each of those arrows that's pointing to something, and I'd like you to try and describe what that is doing to the parent function. Now in this case, we actually know we're dealing with the square root function, because I can see it right there. It's a square root sign. So this is a specific parent function that we've done some things to. So pause your video right now, see if you can go through A, B, C, D, and E using descriptive language, and then in a moment, I'll talk you through each of those. Okay, so I'm assuming you've had a chance to pause your video and have a look. Let's try them out. Here's A first. A is pointing at a 5 there. 5 is out in front. That means it's going to multiply our y values. Our y values is going to make it a vertical up and down stretch, because it's multiplying by 5, so it's going to make those numbers bigger. So it's a vertical stretch by a factor of 5. Vertical stretch by a factor of 5. Okay, let's get rid of that. Let's go to B. B is pointing at this one right here. This is going to affect our x values, so it's horizontal. It's going to be dividing them by 3, so that's going to make them the numbers smaller. So it's a compression, because we're dividing by 3. So it's a horizontal compression by a factor of 3. It's also a reflection. Okay, it's also a reflection in the y-axis. So those are all the words we need: horizontal compression by a factor of 3, and a reflection in the y-axis, with the y-axis acting like our mirror. Okay, let's try C. And let's use red. No, let's use purple for that. C. Oh, I did it all together. B was just pointing at the negative sign. C was pointing at the 3. But I did it all together, so we've already covered all that. So let's move on from C. I guess I'm more efficient than I realize, or I like to believe so anyway. All right, let's do D. Here we go. D is pointing at this one right here. This is going to move us to the left 2 spots. So we're moving horizontally. So this is a horizontal. Translation just means moving, not stretching or squishing. A horizontal translation. And it's going to be to the right in the positive direction. So horizontal translation, right 2 units. Last one, we got E. E is going to be a vertical, up and down, translation, up 4 units. So vertical translation, up 4 units. Okay, so that's the language we would use to describe this. Let's try our next part here, where we're going to try and match each operation by drawing a line from the letter over to the description here, like maybe from here to here, for example. Okay, I just picked a random one. We're going to try and match them up for our transformed function from question 1 above. So pause your video right now, see if you can match each of those up. Okay, I'm assuming you've had a chance to pause it. Let's see if we can figure this out. First of all, let's look at our first one. A is going to be multiplying our y coordinates by 5. B is just this negative. I accidentally put it together with the 3 last time and did it all at once. This is going to multiply our x coordinates by -1, which is going to be our reflection in our y-axis. C, it's pointing at that 3. We're going to divide our x coordinates by 3. D is that -2. We're going to add 2 to our x coordinates. And E, we're going to add 4 to our y coordinates. Okay, so that describes all of the different transformations that we've done in question 1. Let's try doing this with kind of like just a funky graph that we don't have a real function for. So here's our graph, here's our function. Looks kind of like an M, an awkward looking M. And here are the transformations we're going to do right over here. Okay? So we're going to go through each of these points and we're going to think about what we need to do to each of them. First, let's look at our function and I see, okay, I'm going to multiply my y values by -1/2. So basically, I'm going to like flip them and divide them by 2, essentially. Flip them, like reflect them in the x-axis and divide them by 2. I also, for my y values, I need to add 1. They're going to get moved up by 1. For my x values, the only thing I'm doing is adding 2 to them, moving them 2 to the left. Okay, so let's take each one of these points and let's try and go bit by bit. Here we go. Let's start with this point right here, -4, 0. So that would be on our graph 1, 2, 3, 4. That would be right here on our big graph. But this is going to be where we're going to do the translated one. So first of all, we're going to reflect it in the x-axis. Now this is already on the x-axis, so it doesn't reflect at all, right? So it's not going to flip because it's already on the x-axis. It's like sitting right next to a mirror. Now we know we need to add, we need to divide it by 2, divide our y values by 2. Well, our y value is already 0, so dividing that by 2 doesn't change it. So far no changes. We're going to move up 1 and to the right 2. So up 1 and to the right 1, 2. So we're going to end up right here. That's going to be our first point. I'll get out my little eraser and I'll take care of all the other stuff that I moved along the way. Great. Okay, let's try our next one. For our next point, right here, I've got -2 and 2. So that would normally start out 1, 2, 1, 2, like right up here. So the first thing I'm going to do is I'm going to reflect that in the y-axis, or the x-axis rather. So I'm going to actually have it down here, 1, 2. So it would start down here. And then I'm going to divide it by 2 because I got this 1/2 right here. So that would put it right here. And then I'm going to add 1 to it. That would put it right here. And then I'm going to move over 2 spots, 1, 2. That's going to put it right here. So that's our next point. Okay, let's do the one after that. Let's do this point right here on the 0, 0. So normally that would start right here on the origin. I'm going to reflect it. That doesn't change it. I'm going to divide the y values by half. That doesn't change it because they're already 0. I'm going to move it up 1 and over 2. That's going to put it right here. Okay, so I can see already that it looks like the shape I had, but it's flipped over, squished vertically, moved up and over. Okay, so it's going to be kind of the same shape, but it'll be flipped, squished, moved up and over. Now let's look at 2, 3. Okay, so first thing I'm going to do is I'm going to reflect that. So it was up here, 1, 2, 3, 1, 2, 3. It would be down here, and I reflect it. Okay, so let's put that on our graph. 1, 2, 1, 2, 3. If I reflect it, it would be right here. And then I'm going to divide it by 2, so that would put the y value right here. And then I'm going to move up 1, that would put it right here. And then I'm going to move 2 to the right, that would put it 1, 2 right here. So right there. Let's get my eraser and get rid of those dots. Now you might be looking at this and saying, oh, I know it's going to come up, it's going to go like the same amount over and it's going to end up over here. And that's great, but let's go, if you can do that shortcut, that's awesome. But let's go through the process. First of all, we're going to start 1, 2, 3, 4. It would actually start right here. I'm going to reflect it in the x-axis, doesn't change. I'm going to divide the y values, multiply them by a half, or divide them by 2, doesn't change. I'm going to move up 1 and over 2. That's going to put it right here. Let me get my eraser. Okay, there we go. So I see I have a similar looking shape, but it has been flipped, squished, and shifted up and over. And that is my new function after it's gone through those transformations. Now that's kind of painful to do, right? So again, this is why we want to use graphing software and why the thing like Desmos is such a valuable tool for us. Okay, the last thing I want to do is take you to this example, and we're going to put Desmos to work a little bit for us here. We're going to determine a table of values, and then we're going to say the domain and range for the following. So we're looking here at, we started with our parent function of the radical function. So y equals root x, right? Or as we're used to calling it now, f of x equals square root of x. That's our parent function that we're using here. But we've done some transformations to it. So let's see what those are going to look like on Desmos, okay? I've got 3 out front. I've got 1/2 multiplying x plus 1. Let's go to Desmos and take a look at those. Where did I put Desmos? All right, here's Desmos. So let's start filling this in. Let's start with f of x equals, find my square root button down here, x. So there's my basic function. Let's go back and remind ourselves the changes we're making here. We've got 3, 1/2, and x plus 1. Now, if I want a table of values here, I'm going to click that little gear, and I'm going to put a table of values in here. Now, this is a really bad table of values. This table of values is terrible because I got two numbers on here that are undefined, meaning my graph doesn't go there. So, right, because my graph doesn't go into the negative x values at all. So I'm just going to get rid of that. I want to get rid of that. And I'm going to get rid of this one too. There, okay. Now I don't like this 2 because it gives me like a really crazy y value. So I'm going to put in something that I know if I take the square root, it gives me a nice even number. Like 4, the square root is 2. Or if I put in a 9 for x, my square root is 3. So I like those a lot better. So I'm going to take a little snapshot and I'm going to put this on our smartboard and we're going to use this to help us. Alright, so here is my parent function table of values. This is a nice table of values for my parent function. I'm going to need to make some changes to this that are going to suit my transformations. So this is kind of a nice way to do it if you're ever going to do it by hand. Of course, we can easily do this on Desmos, and usually that's what we'll do. But I want to show you what this would look like by hand if we were making our changes. So let's go bit by bit, okay? First of all, let's have y equals 3 root x. That's our first one that we're doing. That's right here. We're multiplying our y values by 3. So our x values are 0, 1, 4, and 9. If we multiply our y values by 3, 0 is still 0. 1 becomes 3. 2 multiplied by 3 becomes 6. And 3 multiplied by 3 becomes 9. So that's my first step. Okay, I multiplied all my y values by 3. Let's keep going. Let's go one step further. Now I'm going to look at my next one here. I'm going to divide rather all of my x values by a half. Now when I'm dividing by a half, that's the same as multiplying by 2. So really what I'm going to do is multiply all of my x values by 2. So I'll put my y values in, leave them the same. Now I'm going to multiply my x values by 2. 2 times 0 is 0. 1 times 2 is 2, and then 8, and then 18. And so this is y equals 3 root 1/2 x. I've done 2 of my transformations. My last transformation is a plus 1, meaning I'm going to be shifting all of my x values 1 to the left. That means I'm going to shift them in the negative direction. So I'm just going to move these tables of values over so that they're kind of out of the way here. And let's do my last table of values. And I'll do my last transformation, just plus 1. I got to subtract 1 from all of my x values. So, I've got x, I've got y equals 3 square root 1/2 x plus 1. Okay, so my y values are going to be the same. My x values, I'm going to subtract 1 from them. So this is going to be -1. This is going to be 1, this is going to be 7, and this is going to be 17. Okay, so that's my new table of values that I'm going to use for my new transformed function. Let's hop back over to Desmos and do these transformations right now. Let's actually put this equation in. So I'm going to make these changes. I'm going to have this as a 3, multiplying my y values by 3. I'm going to divide my x values by a half. And then using brackets, just to be really careful, I'm going to move it 1 to the left. So there are all of my transformations. Now here I've got 0, 1, 4, and 9. Let's try the values that I had here, -1, 1, 7, and 17. So -1, 1, 7, and 17. And there we see, it matches exactly what I had before. Pardon me, folks, I got to deal with a barky dog here. All right, I'm back after dealing with a barky dog. So, folks, I hope this gives you now a better picture of what we're working on when we're dealing with transformations. Today, we're going to have some time to practice together with others and to just do some practice individually. And I hope this will make you feel like you got a nice firm grasp on this stuff. As always, if you need a hand or if you have questions, send them to me on Edsby, and I'll be really happy to help. If you want me to take up homework questions that have been assigned, make sure to send me those as well, and I'll be happy to talk about those tomorrow. That's all for now. Bye-bye.